the degree of the numerator polynomial is less than the degree of the denominator polynomial, then it is a rational function. So when you have the derivative in the numerator and its function in the denominator, you can write it as log of modulus f of x plus c. If it is in the form of improper rational function, we will first convert it into proper fraction and then we will resolve it. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. So in this session, we are taking up the integration by the method of partial fraction. So this is a very important type of question for 3 marks in your examination, you can say. So in our previous session, we have studied integration by substitution of a standard forms. That is 1 over x square minus a square, 1 over x square plus a square, 1 over a square plus x square, and the same 3 types of question under the square root, and we have learned it, we have solved it. So here, let's see what do you mean by integration by the method of partial fraction. Before that, you should have a knowledge of what is rational function, why it is necessary under the partial fractions. Now let's see. So rational function is nothing but a function which is in the form of p by q, where p and q are both polynomial functions and the denominator is not equal to 0. So you might arrive the fractions of the form x square plus 3x plus 2 divided by x square plus 5x plus 6. Then you have to write the integration of this form. So we know that whenever the integrand is given, we always reduce it into standard form, which we have learnt in terms of formula. Either we will reduce it into log x function or any standard functions like sine, cos or whatever in the polynomial function, or any one of the integral of the form x square minus a square minus x square. So whatever the standard forms we have learned, we will reduce these type of polynomials into that form and then we will separately find the integrals. So rational functions is nothing but any functions of the form p of x by q of x, where both numerator and denominator are polynomials. Now I can give a few more examples. For example, x plus 1 divided by x plus 2, x plus 3. So numerator is a linear factor, denominator is a multiple of linear factor, which is a quadratic equation. So here also, whenever you are going to solve this, so the polynomial is converted into linear factors and the linear factors are then separated and then we will find the integral. So these are few examples of rational function. So in rational function, there exist 2 types of rational function. One is proper rational function, another one is improper rational function. What is this proper and improper? So look at the examples I have taken. Here, what is the degree of x plus 1? It is 1. What is the degree of x plus 2, x plus 3? When you multiply, it becomes 2. So whenever the degree of the polynomial in the numerator is less than the degree of the polynomial in the denominator, or you can say degree of the denominator is more than the numerator polynomial, then we say it as a proper fraction. That is, if the degree of the numerator polynomial is less than the degree of the denominator polynomial, then it is a rational function. Similarly, what is the degree of this polynomial? It is 2. What is the degree of this polynomial? It is 2. So I can take one more example. For example, x cube divided by x minus 1, x plus 1. Here in this case, what is the degree of the numerator? It is 3. What is the degree of the denominator? It is 2. So whenever the degree of the numerator is greater than or equal to the denominator. So in this case, they are equal. In this case, it is greater. So that is why improper function is nothing but whenever the degree of the numerator is greater than the degree of the denominator or it is equal to the degree of the denominator, then we call it as an improper fraction. So why this is necessary? Because we can resolve the proper rational function only. So if it is in the form of improper rational function, we will first convert it into proper fraction and then we will resolving. So thus resolving the proper rational function or proper rational fraction is done by partial fraction. So there are different types of polynomials and the factors under the denominator. So based on that, we have clearly given a rule to find out a simple proper fraction by the method of partial fraction. So this is nothing but the process of decomposition of given proper fraction into two or more simple fractions, and then we will apply the integral to find out the integral value. Suppose the rule 1 says you have the polynomial in the form of px by qx. P of x is a polynomial and q of x has to be splitted into factors. So whenever any quadratic equation is given, for example x square plus 5x plus 6 is given, we will have to write it in the form of x plus 2, x plus 3. So that is why whenever the quadratic equation is given under the denominator, it has to be written in form of factors. Then we will write them as a by x plus a for one linear factor, b by x plus b for another linear factor. So if you have minus also, it is nothing but one and the same. Either it is in the form of x plus a or x minus a, x plus b or x minus b. So when you have two factor, split into two fractions. Next, when you have three factors, split into three fractions. So you will get a, b, c, which are constant. Next one, see here the rule 3 is very important again. So previously, you don't have any repeated factors. X plus a is one time, x plus b is also one time, x plus c is also one time. But here in the rule 4, you have x plus b two times. So you have a repeated linear factor. When you got repeated linear factor, the rule is write the first one as it is, write the second one in the form of x plus b, write the third one as the repeated linear. How many times it is repeated? X plus b whole square. Write x plus b whole square only. So repeated linear factors if you have means write as a divided by x plus a, b divided by x plus or minus b and c divided by x plus or minus b whole square. Next, rule 4 says that whenever you can't write it as a factors because some quadratic equation cannot be simplified into linear factors, which we have also saw in our previous session. We made them perfect squares and then we have converted. So in that case, when it is not written in the linear factor, write the quadratic equation as the second proper fraction and write it in the form of bx plus c divided by x square plus bx plus c. So all these constant in the numerator are determined by equating the coefficients of x. Sometimes we may get x square, sometimes we may get x or sometimes constant. So writing these proper fraction into two or more simple fraction, that it may be a sum or difference of two or more simple fractions, is nothing but the method of partial fraction. Now for this type, until here we are going to write a, b, c. We will find out and we will express it in this form, any one of the form, and then we will apply the integration later. So let's take this method now. First one we have find the integral x divided by x plus 1, x plus 2 with respect to x. See here, when you have a polynomial function in the form of p of x by q of x. Now the given equation in the form of first one, x divided by x plus 1, x plus 2. So write the first factor in one fraction, write the second factor in another fraction. So now let's write it, x divided by x plus 1, x plus 2. So next we will get a divided by x plus 1 plus b divided by x plus 2. So the next step is, let me take this as equation 1 first. The next step is multiply this factor throughout the equation. What is the factor you have in the denominator? Multiply that only. Or you can also take LCM on both sides. So when you take LCM on both sides, the same factor you will get, which get cancels now. So if you multiply this both factors here, what happens? Only numerator remains here. Here when you multiply these two, x plus 1 cancels. You will get a into x plus 2 plus b into x plus 1. So this is what the equation you will get. When you take the LCM on both sides, or when you multiply the denominator throughout the equation, you will get this form. What is the next thing? You have two linear factors. Put them as 0. So first one, you have x plus 1. Put x plus 1 is equal to 0. What does it give? X is equal to minus 1. So substituting in equation 2. So once you equate any one of the linear factor to 0, you will get the value of x. Substitute in equation 2. So put x is equal to minus 1. Minus 1 is equal to a into minus 1 plus 2 plus b into minus 1 plus 1. Second term cancels, so it becomes 0. Here we have minus 1 is equal to minus 1 plus 2 is 1. So therefore the value of a is equal to minus 1. Similarly, we will equate the second term now. Put x plus 2 is equal to 0. So this implies x is equal to minus 2. So equation 2 implies. So substitute x is equal to minus 2 in the equation. Then it becomes minus 2 a into minus 2 plus 2 plus b into minus 2 plus 1 it becomes. So now here we have minus 2. Here it get cancelled. So this is 0. B we have minus 2 plus 1 is minus 1. Both sides we can cancel minus. So b is equal to 2. Now you got a is equal to minus 1. B is equal to 2. Substitute the constant in equation 1. Equation 1 implies x divided by x plus 1, x plus 2 is equal to a by x plus 1. But what is the value of a? We have got minus 1. So we will take minus 1 by x plus 1 plus 2 divided by x plus 2. So this is the result. Now apply integral on both sides. So let us apply the integral. X divided by x plus 1, x plus 2 dx. Apply the integral separately because it's a sum. So take minus outside, minus integral of 1 over x plus 1 dx, plus you can take 2 outside, integral of 1 over x plus 2 dx. Now this is in the form of ax plus b. 1 over ax plus b is nothing but log ax plus b. So this becomes minus log modulus of x plus 1 and here plus 2 log modulus of x plus 2 plus c. So this is the answer. So first we will resolve them into partial fractions and then we will apply the integral and then we will find the integral. Next. Integral of 3x minus 1 divided by x minus 1, x minus 2, x minus 3. So when you have 3 separate factors, you have to write 3 simple fractions. So first let us write 3x minus 1, x minus 1, x minus 2, x minus 3. This can be written as a divided by x minus 1, b divided by x minus 2, c divided by x minus 3. Let me take this as equation 1. Now multiply the denominator value throughout the equation. What you will get? You will get 3x minus 1 is equal to x minus 1 cancels. You will get a into x minus 2, x minus 3 plus b into x minus 1, x minus 3 plus c into x minus 1, x minus 2. Take this as equation 2. Now you have 3 factors. So use 3 factors, put it as 0. So x minus 1 is equal to 0 implies x is equal to 1. So put x is equal to 1 in equation 2. Now equation 2 implies if you take x is equal to 1 here, 3 into 1, 3 minus 1, a into 1. You have to take 1 minus 2, 1 minus 3. B 1 minus 1, 1 minus 3 plus C 1 minus 1, 1 minus 2. So now you can see 1 and minus 1 cancels. So 0 into anything is 0. Here also 1 minus 1 cancels. So 0 into C is 0. Now here you have 2A minus 1 minus 2. And this is 0, 0. So you have minus 1 minus 2 is 2. So 2 is equal to 2A we have. So 2 get cancelled. So therefore the value of A is equal to 1. Now similarly take x is equal to 2 and x is equal to 3 after equating to 0. So next x is equal to 2 we get. So therefore equation 2 implies 3 into 2 becomes 3 2s are minus 1 is equal to A into, so 2 minus 2, 2 minus 3 plus B into 2 minus 1, 2 minus 3 plus C into 2 minus 1, 2 minus 2. So clearly the first term and the last term cancels because it becomes 0. Now here we have 6 minus 1, 5, 0. We have B, 2 minus 1, 1, 2 minus 3, minus 1. So this implies B is equal to minus 5. Next, let me take x is equal to 3. If you take x is equal to 3, equation 2 implies 3 into 3 minus 1, A into 3 minus 2, 3 minus 3 plus B into 3 minus 1, 3 minus 3 plus C into 3 minus 1, 3 minus 2. So clearly A becomes 0, B becomes 0 and now we have only C factor. Here 3 3s are 9, 9 minus 1 is 8. C into, so 3 minus 1 is 2, 3 minus 2 is 1. So we can cancel 2 1s are 2 4s are. So therefore C is equal to 4. Now equation 1 implies that is 3x minus 1 divided by x minus 1, x minus 2, x minus 3 can be written as A divided by x minus 1. What is the value of A? 1. So it becomes 1 divided by x minus 1 and B is minus 5 divided by x minus 2 and C is 4 divided by x minus 3. Apply the integral on both sides. So integral of 3x minus 1, x minus 1, x minus 2, x minus 3 into dx is equal to integral of 1 over x minus 1 dx. Next we have minus 5 outside, take it outside. Integral of x minus 2 dx. We have 4 as a constant, take it outside. Integral of x minus 3 dx. So what happens? Everything is in the form of 1 over ax plus b, which is nothing but log of modulus ax plus b. So this becomes log of x minus 1 minus 5 log of x minus 2 plus 4 log of x minus 3 plus c. So this is the integral value of the given simple rational function. Next one, integral of 3x minus 2 divided by x plus 1 whole square x plus 2. So how to write this? Since here you have a repeated linear factor. So when you have a repeated linear factor, you have to write one in the form of a simple fraction. The second one you have to write it in the form of square only. So therefore here I can write it as 3x minus 2 divided by x plus 1 whole square x plus 2 can be written as a divided by x plus 1 plus b divided by x plus 1 whole square plus c divided by x plus 2. Now multiply the denominator throughout the equation. So let me take this as equation 1. Then the equation become 3x minus 2 is equal to a into x plus 1 x plus 2 plus b into x plus 1 whole square get cancelled. So we are left with only x plus 2 plus x plus 2 cancels. We are left with only x plus 1 whole square. So this is equation 2 now. So now here, see here we have two linear factors. One is x plus 1, another x plus 2. So put x plus 1 is equal to 0. We get x is equal to minus 1. So put x is equal to minus 1 in equation 2, then what happens? If you put x is equal to minus 2, if you put x is equal to minus 1, it becomes minus 3 minus 2. If you put minus 1 here, a into minus 1 plus 1, minus 1 plus 2, plus b into minus 1 plus 2, plus c into minus 1 plus 1 whole square. So minus 1 plus 1, minus 1 plus 1. So wherever you have minus 1 plus 1, that constant becomes 0. So here you have minus 5. So this is 0. Minus 1 plus 2 is 1. 1 into b is b. So therefore, value of b is minus 5. Next we take x plus 2. So x plus 2 is equal to 0 means x is equal to minus 2. So equation 2 implies, if you put minus 2, 3 into minus 2 minus 6, minus 2 is equal to a into minus 2 plus 1, minus 2 plus 2, plus b into minus 2 plus 2, plus c into minus 2 plus 1 whole square. So now here we have minus 8, minus 2 plus 2 0, so 0 into a is 0. Minus 2 plus 2 cancel, 0 into b is 0. Next we have minus 2 plus 1, which is minus 1. Minus 1 square is 1, so you'll get c. So therefore, c is equal to minus 8 you have got. Next we need to find out the value for b. So if you have 3 factors, it is easy to find out all the 3 constants here, but here you don't have all the 3 factors. So since you have only 2 factors, the other way you have left it, you can put as x is equal to 0, or you can equate the coefficients of x on both sides. So look here, so this is the equation. So let me equate the coefficients of x square on both sides. So I'll write equating coefficients of x square on both sides. So this method is used whenever you don't know any other third factor to replace the value of x. So here, observe this equation. Do you have any x square term here? No. So therefore, on the left hand side, you can rewrite as 0. Next. So here, can you see any x square term here? Yes, you can see, because x plus 1 into x plus 2 means when you multiply x into x, it becomes x square. Outside you have a constant a. So therefore, what is the coefficient of x square in this term? It is a. So just write it here, a. Next, see the constant. It becomes bx plus 2b. So you will not get x square constant. If you expand x plus 1 whole square, you will have a term x square. Then it becomes cx square. So therefore, you can take the coefficient of x square as c. So here you can write plus c. Now here you got value of b, you got value of c. So what else you need here? You need a. So therefore, a is equal to minus c. So this implies, what is the value of c? We have minus 8. Minus of minus 8 is 8. So therefore, the value of a is 8. So therefore, the equation 3x minus 2, x plus 1 whole square, x minus 2 can be written as a divided by x plus 1. That is nothing but a divided by x plus 1. And b divided by x plus 1 whole square. So plus minus 5 x plus 1 whole square. Next we have plus c divided by x plus 2. So what is the value of c? We have minus 8 divided by x plus 2. Now next, once we got this, we can apply the integral. So what happens? Integral of 3x minus 2 divided by x plus 1 whole square, x minus 2 dx is equal to, you can take 8 constant outside, 1 over x plus 1, you can write dx here only. So next you have minus y integral dx divided by x plus 1 whole square, and you have here minus 8 integral dx divided by x plus 2. Now the first one and the third one is in the form of ax plus b, 1 over ax plus b. So you can write it in the form of log ax plus b. But here this is in the form of 1 divided by x square. So when you have 1 divided by x square, what is the integral of 1 by x square? So integral of 1 by x square dx. So this is nothing but x to the power minus 2 dx. So it becomes minus 2 plus 1. So here you can get this in the form of minus 2 plus 1 is nothing but x to the power minus 1. So we can write this as minus 1 by x plus c. So therefore here also you can write it as 8 log modulus x plus 1 for the first one minus 5. So here you have 1 divided by x square plus 1 whole square. So this can be written as 1 divided by x plus 1. Minus you have to write, so this becomes plus. So when you have x plus 1 whole square in the denominator, it reduces to less than 1 power minus 8 log of modulus x plus 2 plus c. So this is the integral of the given form of rational function. Next one, integral of 2x divided by x square plus 3x plus 2. So whenever any quadratic equation is given, split into simple linear factor. So this can be written as integral of 2x divided by x square plus 3x plus 2 can be written as x plus 2 x plus 1 into dx. Now take this rational function or a proper fraction. So this can be written as a divided by x plus 2 plus b divided by x plus 1. So take it as 1, multiply with the denominator, then this is 2x is equal to a into x plus 1 plus b into x plus 2. Take this as equation 2. Now you have two factors, put x is equal to minus 1, then equation 2 implies put x is equal to minus 1, this becomes minus 2. And here you have put x is equal to minus 1 plus 1 cancels. So this term becomes 0. Next you put x is equal to minus 1. You have b minus 1 plus 2 is 1. So therefore the value of b is minus 2. Now similarly if you put x is equal to minus 2, then equation 2 implies minus 2 into 2 is minus 4 and minus 2 plus 1 is minus 1a which becomes minus a. Minus 2 plus 2 cancels, so therefore second term is absent. So therefore we can take value of a is equal to 4. Now we got what is a, what is b. So therefore integral of 2x divided by x square plus 3x plus 2 dx is nothing but integral of 2x divided by x plus 2 x plus 1 dx. This is nothing but, so what we have got, two separate fractions we have to take, that is integral of a divided by x plus 2. What is the value of a? It is 4. So 4 divided by x plus 2 into dx plus integral of, what is the value of b by x plus 1, which is minus 2 divided by x plus 1 into dx. So take 4 as a constant outside the function. Integral of 1 over log x plus 2 becomes log of x plus 2. And here take minus 2 constant outside. Integral of 1 over x plus 1 is log x plus 1 plus this integration constant. So this is the given value of integral. Next one we have integral of 1 over x into x square plus 1. See here, I can write 1 divided by x into x square plus 1 as a divided by x. Don't worry if you don't have any constant, write it in the form of ABC only. But x square plus 1 cannot be divided into two linear factor. If it is in the form of x square minus 1, then I would have written in the form of x plus 1, x minus 1. But this is not possible. So that is why whenever it is not possible, we mention this method. We write numerator in the form of bx plus c and denominator as x square plus 1 only. So now we have the equation equated. 1 is equal to a into x square plus 1 plus bx plus c into x we have. So this is 1, this is 2. So now here, let me put x is equal to 0 in this equation. If you put x is equal to 0 in this equation, then here 1 is equal to a into 1. So 0 into anything is 0. So therefore, the value of a is 1. So next, I don't have any other factors to equate. So let me take the coefficients to equate. So if you don't have any other factors, then use this method, equating coefficients of x square on both sides. Find any x square term on both sides. So on the right hand side, you don't have anything, so 0. On the left hand side, it is a. And here you have bx into x becomes bx square. So therefore, you can take b as a coefficients of x square. Now you got a is equal to 1. So this implies b is equal to minus a, which is nothing but minus 1. So therefore, the value of b is minus 1. Next, we need to find c. C is a coefficients of x. So let me equate coefficients of x on both sides. So do you find any coefficients of x term here? No. So therefore, on the left hand side, it is 0. On the right hand side, it is ax square into a. So this is not the coefficient of x. Next, it is bx square plus cx. So this is a binomial term you can take. So bx into x is bx square plus cx into x is cx. So therefore, the coefficient c is 0. So therefore, c is equal to 0. Now we got all the three terms here. So therefore, let us write it. Now 1 divided by x into x square plus 1 can be written as a by x. What is the value of a? 1. So it is 1 by x. Plus value of b is minus 1. Value of c is 0. So it is minus 1 into x plus 0 divided by x square plus 1. So this can be written as 1 by x minus, so here you have x divided by x square plus 1. Let us integrate on both sides. So integrating 1 by x into x square plus 1 with respect to x. So let us integrate it separately. Integral 1 by x dx minus integral x divided by x square plus 1 dx. So the first one, clearly you can write it in the form of log x. The second one, use the substitution method. So we have integral of x dx by x square plus 1. Put x square plus 1 is equal to t. Then 2x dx is equal to dt, or x dx is equal to dt by 2. So therefore, this equation becomes integral of dt divided by 2 into t. So we can write it as 1 divided by 2 into dt by t. So what is integral of 1 by t? It is log t. But what is t we have taken? So t we have taken as half of log of x square plus 1. So this is the answer. So directly, you can also use the integral formula other than this, that is integral of f dash of x divided by f of x dx can be written as log of f of x plus c. So this is one more important standard form which we have learnt previously. So when you have the derivative in the numerator and its function in the denominator, you can write it as log of modulus f of x plus c. So that is why this can also written as minus log of modulus x square plus 1 plus c. So this is the integral of the given rational function. So like this, whenever you have any rational function, we'll resolve it into simple fractions by the method of partial fraction, and then we will apply the integral, and then finally we will find out the integral value of each rational function. So we'll meet you in the next session. Until then, keep watching, keep learning, keep exploring. Thank you.